Hi everyone, this is Janine aka Janine The Tutor. Thank you so much for tuning in. I just wanted to go over the popular questions that we've been getting for math on One Class Homework Help. So that's what today's class will be about. And also, I know now is not really a good time to be sorry. I know that now is a very difficult time for all of us, right, as students, just because I think it's really hard to transition from that in-person class that we're used to online, and hopefully I am able to help you out. Like as a part of one class, we are very fortunate that we are able to adapt to the circumstance quickly, and that's why we want to extend our helping hand for you students to stay on top of your studies. So let's dive deep into the questions right now. Okay, so hopefully you guys can see my screen and you can hear me coming through. If you're coming in from Facebook or YouTube, can I get a yes? Just so I just want to make sure that you can see my screen, which there's two panels. This is a whiteboard over here, and you have the question, as well as if you can hear me coming through as well. Okay, great. So for the first question, so we're looking at coterminal angles. Let me just select the pen. Okay, great. So they're asking us which expression finds the measure of an angle that is coterminal with a 45-degree angle, right? So first of all, let's just define what a coterminal angle is. If you recall, back to math class, right? If you have a coterminal angle, so say for example, you have a 45-degree angle, that means you're going to share the same initial side, right? Let me draw that. Okay, so you have your quadrants, right? So respectively, you have quadrant 1, 2, 3, and 4. So what a coterminal angle is, so say for example, I'll give you just a really quick one or a simple one. So if you have, let's say, 45 degrees, right? So I'm starting from quadrant 1, right? And this is 0 degrees. So this could also be in radians, right? But because we're focusing on degrees, so that's what we're going to focus on. And because it's a positive 45-degree angle, that means it's going to come from this 0 degrees as opposed to the other way around. Does that make sense? Because otherwise, if you have negative 45 degrees, then you're going to start from the bottom, right? So it's counterclockwise for positive 45 degrees, and if it's clockwise, then it's going to be negative 45 degrees. But because we want a positive one, right, let's focus on that. Great. So we have this initial side, right, which is this 45 degrees, right? So if you have a coterminal angles, right, because they're giving you 250, 370, 180, and negative 360n, right, it's either you add or subtract, right, depending on the given angle. So right here, your coterminal angle, right, you're going to be sharing that initial side. So that means the coterminal angle would be this angle over here, right? Okay, great. So I think I've covered that. Okay, so let's get into the question. So maybe let's look at what they wrote. So here for part A, they're saying you have 45 degrees and you have 250 and degrees, right? So remember, because it's supposed to be a coterminal angle, that means you need to have degrees, right? Sorry, this is your angle first, and this is equal to your angle that you're looking at. So this is the total angle if you think about it. And this is your angle, which is the 45 degrees, and this is plus. So this is supposed to be 360, right? Because when we're looking at coterminal angles, right, we're looking at the entire quadrant, right? So if you remember a reflex angle, it's like 360 degrees, right? It's like one big circle. So that's why you have 360, and depending on what your teacher uses for the variable, it could be n or k. So let's say we're using n because that's what the question is telling us, and you have degrees over here. Okay, so let's see. Because they're adding, right? So as you can see, okay, so they told us that D is true, which is this part. Okay, so let's try to read what they have. So it says two angles, theta 1 and theta 2, are called coterminal angles if they have the same initial side and same terminal side. That's right. Okay, great. So when they say initial side, for example, remember the 45 degrees that I mentioned? So this is the initial side, right? And you have another angle that's going this way, right? And this is your terminal side. Okay, so that's what theta 1 and theta 2 is. And it says when you subtract the 2, you get 360, right? Where m is an integer. And if it's not equal to 360, basically it's not coterminal. So when they say you have an m over there, what that means is it needs to be a multiple of 360, right? That's why you have an integer. So in that case, it could be 360 degrees times 2, right? If you have 360 degrees times 2, that would be 720. So 720, if the two angles sum up to 720 degrees, that means it's still going to be coterminal, right? And let's say you're looking at 250n, right? So what they showed you, right? So let's say you have 45 and you have plus 250n. So they're saying that let n be equal to 1, right? So if you add a 2, you get 295, right? So this 295, this is theta 2. Does that make sense? And you have theta 1, which is 45 degrees. So if you have 45 and you have 295, when you subtract the 2, you get 250 degrees, right? So theta 1 is 45 and you have theta 2, which is 295, right? So the most important thing here is if you see that 250 degrees is not a multiple of 360, right? That means it's not going to be coterminal. That's why A is false, right? Now let's move on to part B. So for part B, they're saying you have 45 degrees, then you have 370n degrees for any integer n. Okay, so let's go to B. Now you have n is equal to 1, great. So we have 370 degrees, right? We sum up the two. We say that 45 degrees is theta 1. Then you have 415 degrees, which is theta 2. Remember, we need to subtract the 2, right? Based on the formula. So yeah, this theta is equal to theta plus 360n. If you rearrange this equation, you can say that you're subtracting the 2. Okay, so you have 415, right? And then you have 45 degrees, so that's equal to 370. We know that 370 degrees, regardless of whether you have an integer of 1, 2, or so on and so forth, it's not going to be a multiple of 360, right? I think it's pretty obvious. So that's why we're going to say that B is false, and this is correct. Now, if you move on to part C, right? So for part C, they're saying that, let's see, 45 degrees, right, over here, plus 180n degrees for any integer n, right? So I think they're using 1 again for n is equal to 1. And let's keep it simple. You don't have to go and use n is equal to 2 or 3 or 5, right? As long as you keep it as the lowest number possible, right? Just keep it simple because all you want to do is to identify whether your angle is going to be a multiple of 360, right? So as you can see, if you have times 1, right? Remember, it's 45 plus 180n, so 1 being n. So you multiply that to 180, you get 225 degrees. Great. So we know that the second theta, right, or the second angle is 225, right? So now we're comparing 225 degrees and 45 degrees. So when you subtract the two, you get 180, right? So as you can see, 180 degrees is not a multiple of 360, right? So that's why C is false, and that's correct. Now let's move on to part D. Okay, so as you notice, basically they took 45 degrees plus negative 360 n degrees, right? So let's say you keep that n being 1, the same thing as what we did earlier. So because you're supposed to add the 2 first, right? So this would be 45, then you have minus 360 times 1. Remember, because n is 1. So this is actually negative 315, right? And when you add the 2, right? Because remember, negative 315, negative 315 degrees is basically your second angle, right? That's theta 2. So if you take 45 degrees and you take negative 315 degrees, and so far what we've been doing is we're taking the two angles. So let's say you have negative 315 minus 45 degrees, you're going to get negative 360. Okay, so Let me try to illustrate that, just because I think what they did was they combined the two equations right off the bat. So that's why it's pretty confusing, I would say. So because so far from A to C, they're breaking this down into two equations. As you can see, they're adding the two and then they're subtracting. So maybe I can show you that. Okay, so you have 45 degrees. That's the angle. And then they're saying that you have a negative 360n, right? So you're supposed to add, so let n be equal to 1. And then you're saying that you have 360 times 1, right? That's your n. And that's going to be in degrees, right? Like the whole thing. So when you add the 2, and this is supposed to be negative 360. And how did I know that? Well, if you look at this, right, it says negative 360n. So this is going to be 45 minus 360. So you're supposed to get negative 315 degrees, right? So that's our angle. And then if you look at this, what are we supposed to do? We're supposed to take the two angles, so this being theta 1. Again, you can reassign this being theta 2, it doesn't really matter, but as long as you get the multiple of 360, you should be fine. Okay, so I'm taking theta 2, which is part of this formula, right? So as you can see, if you have to apply this formula, right, which is theta 1 minus theta 2, right, you get 360. Or you can just take theta 2, which is what they've been doing so far, right? Theta 2, which is negative 315 degrees. And then you take you subtract the 2, right? And then you take theta 1, which is 45 degrees, right? We know that this is a positive angle, therefore you have the negative sign. When you distribute that, you get negative, right? So when you add the 2, right, technically it's negative 315 minus 45. So adding the 2, you would get negative 360 degrees. Okay, so can you guys see that? So now you know that negative 360 degrees is actually a multiple of 360, right? So that's why D is true, right? And that's what they said. D is true. And this is correct. So okay, great. I don't have anything to correct. I guess for part D, I just wanted to break it down even better into two equations. That's my only comment, but regardless, I think this is a perfect solution. So maybe we can leave that. Okay, so we said we wanted to have 45 degrees, two solution. Okay, so this is the two solutions. So we have 45 degrees, and then we have negative 360 times 1, and this is degrees. So we're going to get negative 315. Okay. Okay, so we had negative 315 degrees, and then the next step would be to have negative, actually 45, right? Sorry. Negative 315 degrees. And then we had minus 45 degrees.
It's 113 degrees Fahrenheit.
Okay, great. I apologize for that. Apparently, I think the Siri in my computer just like turned on. So can you still hear me? Okay, great. Anyways, let's go back to the question. Negative 45 degrees, and we said it was negative 360 degrees. Okay, great. So that's my comment. Solution is correct. Perfect. Okay, so let's move on to the next question. Okay, so here we have a geometry question, and we're trying to figure out, so this is HL over JL, which is equal to IL over KL, is also equal to what ratio? And for the next question, it says if triangle HLI is similar to triangle JLK by SSS similarity theorem, then HL over JL is equal to IL over KL is also equal to what ratio? Okay, so let's try to draw this triangle. Okay, so they're saying that we have two triangles, which is triangle HLI, which is similar to triangle JLK. And first of all, when two triangles are similar to one another, right, that means the sides are going to be equal, right? Or proportional. Sorry, not equal, but proportional, right? So when we have something that's proportional, right, it just so happened that the way they drew the two triangles, right? They look like the dimensions are similar, right? But the whole point of similarity theorem is the sides are proportional, so they're not necessarily equal, right? So if you have HLI, so they had, okay, so apparently the second triangle is HLI, but I'm going to write that as the first triangle. So we have H and you have L and this is I, and then you have JK, JLK rather. So yeah, just by looking at the figure, when two triangles have proportional sides, they're not saying that they're congruent or they're not equal to one another. It's proportional. So the proportionality is different from two triangles being congruent. Okay, so I just wanted to put that out there. So if you have JLK, okay, so that's the pink triangle that they have here. Yeah, I just wanted to have the first triangle being HLI just because I think it's reasonable to have this statement and you have the first triangle being HLI. So, okay, great. So now they're trying to say that you have HL over JL. So as you can see, HL is over here and you have JL, which is over here. So here's the thing, when you're trying to write up a proportionality theorem, so it's a ratio, right? You need to have the two sides that are proportional. So say for example, you're looking at HL, right? So you have this HL over here. You're going to say that this, right, is going to be proportional to the other triangle, right? So you're supposed to have the numerator, right, from one triangle, right? So that's one segment, and then the other one would be JL, which is coming from the other triangle. And this is going to be equal to IL, which is right here, and you have KL, which is right here. So it's really important to split up your triangles, right, into two equations, right? Or two fractions, rather. So one triangle is coming from this segment, and then the other side, right? So we said we had HL, so the other side was IL, so that's for another fraction, if that makes, yeah, if that makes sense. So you have IL and this is over KL. Okay, so this is going to be equal to what ratio, right? Because it's the SSS theorem, right? So you're saying that all of the three sides of your triangle are proportional, right? That's why they need to come up with, let's see what they wrote. Yeah, so they need to come up with another side of the triangle, right? So because they're saying that you have this HL and you have this over here, so you need to have your IH or HI and this KJ over or JK rather. So it's up to you whether you're trying to name this as IH, right? Just make sure it's consistent. If you read it as IH, it has to be KJ. And if you read it as HI, it has to be JK. So based on this SSS theorem, you can say that this should be equal to HI, right? So, and how do I know the numerator needs to be HI? Well, you're referring to triangle 1, right? So I'm saying that HLI is your triangle 1, right? So as you can see, your numerator all of your segments, right, or sides of your triangle are coming from triangle one. So you need to be consistent. So that's how you write your proportionality ratio, right? So if you have HL to begin with, you have IL over here. So now you know that your numerator needs to be coming from your triangle one. Does that make sense? And then because you're saying it's HI, then you need to read this as JK over here. So all of your denominator from this point to this point, right? They're coming from triangle 2. Okay. So hopefully that was clear because this is the SSS theorem, so that's why it has to be sides, right? We're not looking at angles here. Because being proportional, right, for the three sides, because it's SSS, it doesn't mean that your angles, right, all of this angles inside, they're going to be exactly the same, right? However, because it's based on the SSS theorem, right, you can say that this angle L is going to be congruent to the other angle over here, right? Does that make sense? Because they're similar, right? But you cannot say that based on the SSS theorem, all of this, or in other words, you're going to say that this is an equilateral triangle, right? You cannot say that. You can only say that this angle would be congruent to the other angle. Over here, this angle is going to be congruent to this other angle K, and this angle H is going to be congruent to this angle J. So that's all you can say for SSS. But yeah, but the whole point of this question is not to say that the angles are going to be congruent. It's just looking for the other ratio. Great. So let's see what they wrote. Okay, so this is what I said. Remember, you have angle H, which is congruent to angle J, so that's right. You have angle L, which is congruent to angle L. It just so happened that this is also angle L, but it doesn't necessarily need to be the same letter, okay? So it could be, this could be P, right? It doesn't have to be the same letter. It just happened coincidentally that but they're both L. So this and this needs to be congruent, right? And you can say that I and K, they're also congruent. So yeah, that's it. That's basically right. So the two of this, yeah, two of these answers basically are right. So I have nothing to correct. So this is perfect. Okay, great. I think we can move on to the next question. Solution is correct. Okay, so here's the next question. It says, how much does a gallon of milk weigh? Okay, so interestingly, they actually brought up a concept where they're talking about the weight and also volume and density, right? So first of all, if you recall, right, what is the unit for density and how did they came up with this formula, right? So, and also we actually need the units for gallons, right? So apparently they're saying that the density that we're going to be using is 8.6 pounds per US gallon, right? So this is density, which is equal to 8.6. This is gallons, and this is this is pounds. So LBS. So yeah, I'm just abbreviating pounds to LBS, and this is per gallon, right? Okay, so they actually brought up this equation, which is weight is equal to volume times density. Okay, so when you try to look at the units even closer, right, you know that for volume, typically when they're looking at the English metric system, so that's why they had this US system over here. They're talking about the English metric system as opposed to SI units, because for volume, typically we would use liters, right, as opposed to gallons for SI units, right? And sometimes we would even use centimeter cube, right, for capacity. So for volume here, we know that the unit needs to be in gallons, right? And why does it need to be in gallons? Well, if you have to multiply this to the density, which for example is pounds over gallons, right? You can see that you can cancel out gallons and just have pounds, right? So weight is, or actually weight can be measured in terms of pounds as well, right? So That's why you know that this equation holds true, because if you multiply volume times density, you simply get pounds, right? And that's right. So, yeah, they're assuming that the volume of milk that is given is 1 gallon, which I think it doesn't really say from the question. So I think they should have provided us with the measurements, right? So I think they should have mentioned that the density of milk is 8.6 and this volume of milk is 1 gallon, right? They need to tell us that. Otherwise, there's no numbers you can actually deal with. So because they're saying you have 1 gallon, so this is just going to go here. And remember, this is unit analysis or dimensional analysis. And they're saying we have 8.6 pounds per gallon, right? As you can see, we can cancel the units, right? Remember, this is unit analysis. And we just get 8.6 pounds. So this should be the weight of a gallon of milk. And that's what they have here. Okay, so I have no comment because everything is right, so great. Next, yeah, so for this question, they're asking you what is the square root of 180 simplified in radical form, right? So first of all, what does it mean when it's a radical form, right? So if you're taking a square root of 180, the way you're going to write this, right, is going to be like this, right? Yeah, I know that radicals may seem overwhelming for some students who are learning this for the first time, but honestly, if you understand this, this is like the easiest. So if you have square root, right, typically we say that the square root of 180 or any other number, right, the index is 2, right? So when you say cube root, you would have 3. So this is what you call your index, but for square root, we don't typically write 2. So if you don't see any number, that means it's a square root, right? So that's how we write radicals in terms of an index of 2. Okay, so they had this calculation here, but I didn't really like this because just to make this whole thing more, I mean, simpler, right? So if you have square root of 180, all you have to do really is use your, what do you call this? Least common multiple, right? The way you're going to use synthetic division. I'm not sure if you've learned this in class, but this is my technique. Okay, this is Janine the Tutor's technique. So you take 180, right? And this is the fastest way to do it. So you take 180 and all you have to do is think of prime numbers, right? So keep it simple. Prime numbers like 2, 3, 5, and so on and so forth, right? So I'm going to use 2, right? Because I know that 180 is divisible by 2. And how do I know that? Well, 180 is an even number, right? So if your last number is an even number, therefore it's divisible by 2. So that's how I know. So 180 divided by 2 would give me 90, right? So as you can see, 90 is an even number, right? It ends in 0, therefore I can divide this with 2. It's divisible by 2. So 90 divided by 2, I get 45, right? So now that I have 45, I can use 5 to divide 45 with 5, right? And why? Because this number over here, right? If it ends in and is, sorry, if a number, right? So say for example 45, it ends in 0 or 5, that means that number is divisible by 5, right? So as you can see, it ends in 5, therefore 45 is divisible by 5. So if you have 45 divided by 5, you get 9, right? We know that 9 is divisible by 3, so that's why you get 3. So in order to simplify the square root of 180 in radical form, all you have to do is combine the numbers in pairs, right? Does that make sense? Because if you have the index of 2, right, you need to combine the numbers in pairs, right? So as you can see, you have 2, you can form a pair because there's 2 numbers of 2. And for 3, you can also form a pair. That's why it's an index of 2, right? Because you're supposed to group them based on 2 numbers. And as you can see, there's one number that's left, right? So the number that is left over here is going to be the one that will be left inside your radical, right? So in that case, this is a 2, right? So when you rewrite 180 in terms of the square root, you're going to have 2 times 2 and this is times 3, times 3, times 5, right? So when you actually group this, right, remember this is 4, right? 2 times 2 is 4. So when you're taking the square root of 4, it's actually 2, right? So that's why this is going to be grouped together as 1. So you take that out as 2, right? Because the square root of 4 is 2. And then you have 3 times 3, which is 9. So the square root of 9 is 3. So you multiply this to 3, and that's why you get 6, right? Outside. And whatever is left that doesn't form a pair, right? That's going to be inside your radical. Does that make sense? So that's why you have square root of 5. And as a result, your answer should be 6 square root of 5. So this is your final answer. And I think they did a couple of steps here, but I think this is the most straightforward step. So, and also the way they wrote this, right? It says the square root of 180 is plus or minus 13.41. Okay, so it's not even exact, because if you take your calculator with you, you take the square root of 180, right? So in terms of decimal, this is actually 13.41640786, and so on and so forth. So I think the best answer would be 6 square root of 5. So that's just my comment. I think it should be 6 square root of 5. So, okay, so yeah, hopefully you guys understand this. And also, just keep in mind, because the index of a square root is 2, right? Let's say if it was a 3, then all you have to do is group the numbers in terms of 3 numbers in a group. Does that make sense? So instead of having just 2 numbers, make sure it's grouped into, so one group would consist of 3 numbers and they need to be identical, right? So instead of having just 2 twos, right, you're going to have 3 of your twos, right, grouped together. So that's how you're going to simplify any type of radical depending on the index. Okay, so the answer should be 6, and you have square root of 5. Okay, so the solution is incorrect. Okay, let's move on to this question. It says, which equation can be simplified to find the inverse of y is equal to x squared minus 7? Okay, so I know it's a little bit confusing to just look at the series of equations and you have your 2 with that hat symbol. So maybe we can make that better by writing that out. Okay, so first of all, the question is y is equal to x squared minus 7, right? And we're supposed to find the inverse, right? Or can be simplified to which of the following options, right? So first of all, for part A, we have x is equal to y squared, and this is minus 1 over 7. Then for part B, this is going to be 1 over x, which is equal to y squared, and this is minus 7. For part C, we have x, which is equal to y squared, and this is minus 7. For part D, we have negative x, and this is equal to y squared, and this is minus 7. Okay, so the whole point of this question is not to find the inverse exactly, but you need to rearrange your equation such that you're going to match any of this, right? So it's sort of looking for the step to get to the inverse. Okay, so first of all, how do we find the inverse of a function, right? So if you have y is equal to x squared minus 7, when you're supposed to find the inverse, all you have to do is you flip the two x and y, right? So this y becomes an x and this x becomes a y, right? So you're going to say that this is x is equal to y squared minus 7. Does that make sense? Okay, great. So because it's only a step that we're looking for and the thing that matches that would be C. That's why the answer should be C. And this is correct, right? Just so the question is asking, what's the inverse, right, of this function y is equal to x squared minus 7? Now, the first step is to switch them up, right? If you have y, it becomes an x, and if you have an x, it becomes a y, right? So all you have to do is you isolate y the same way you're isolating any type of function, right? So if you have x, this becomes plus 7 and you have y squared, right? So because this negative 7 goes to the other side, it becomes positive. And then you take the square root of both sides, right? So you would have y, which is equal to plus or minus square root of x plus 7, and this is your inverse function. Great. So yeah, this is correct. So nothing to correct. Okay, solution is correct. Great. Okay, so here's the thing with radicals, right? And just so you know, 53 is a prime number. That's why you can't really simplify 53, because if it's a prime number, remember, it's only going to be having factors of itself and 1, right? So 53 times 1 is going to be 53. So you only have two factors, which is itself and 1. That's why you cannot really simplify the radical form of 53. So when you simplify this, right, it's still going to be the square root of 53, right? If that's what they're referring to. So, so I believe, yeah, they're saying it's square root of 53, so this is right. And then they're giving you a couple more examples, which is not really relevant. So, square root of 53, right? Simplified form is still going to be itself, right? Why? Because it's a prime number. 53 is a prime number. So, and also for prime numbers, I know it's kind of difficult to memorize all of your prime numbers, but that's the only way to go. There's no trend. Because I know some students, they prefer trying to memorize the trend as opposed to just the numbers, right? So all you have to do really for prime numbers is to know them by heart. So solution is correct for this question. Okay, great. For this part over here, it says which diagram could be used to prove triangle ABC is similar to triangle DEC using similarity transformations. Okay, so I know they're drawing a couple of images over here, but I think the most important part is to focus on the question, right? So if you can take a look at this, right? Can you see angle A, right, and angle D, right? So because they're saying the two triangles, right, specifically A, B, C, right, and they have D, E, C, right, because they're saying that they're similar, right, so you can actually use the angle similarity theorem where you can say this angle A is going to be congruent to angle D, and you can say that angle C is going to be congruent to itself, right, for the other triangle. And in that case, you can use this. So you can say B or angle B is congruent to angle E. So you're going to use the angle similarity theorem. Yeah, it's supposed to be angle, but because if you have two angles that are congruent, right, for the two triangles, then that means the last angle is going to be congruent as well. That's why it became AAA, right? So, let's see what they wrote. So they're saying it's part A that is true. Okay, so yeah, this is true. And let's see. First of all, for part B, this is going to be incorrect because if you're saying you have ABC, okay, maybe I can write that here. So triangle ABC is congruent to triangle DEC. So let's take a closer look at B. Okay, so you have ABC, right? And you have DEC. So the way they actually drew the triangle for the angles, right? This is supposed to have two tick marks, right, over here. So that's why this is incorrect. So B is incorrect because you're supposed to have this angle B and angle E congruent, and you're supposed to have angle C and angle C congruent, not the other way around, because what they've drawn is this angle C is congruent to angle E. That's why it's incorrect. So, and for part C, right, because they're saying you have ABC and you have DEC, angle B and angle D should have the same angle, right? They're supposed to be congruent, not angle B and angle C, right? So it should be angle B is congruent to angle E, and you should have angle C is congruent to angle C. That's why this figure is incorrect. And for part D, this is going to be incorrect because you need to have at least two angles that are congruent to the other triangle, right? For the similarity theorem to hold true. So that's why it's angle A. Sorry, it's part A, not angle A. So let's see what they wrote. Because angle ACB is not equal to angle DCE. Yeah, so that's what we said, right? So we had ABC is not equal to DCE. That's true, yeah. So that's their explanation. And for part C, they're saying here there is no relation between the corresponding angles of the triangles, hence they cannot be similar. We have angle ABC is equal to ACB, which is 50. Okay, by the way, the 50 degrees and the 45 degrees is something that they just came up, but the whole point here for part C is you need to say that angle B and angle E should be congruent, not this angle C and angle B. So you don't need to assign numerical values for your angles, right? But if it helps, then go ahead. But to answer this question, you don't need to bring up numerical values for your angles. Okay, so for part D, it says we have a right angle at B. For the given two triangles to be similar, there must be a right angle in angle DEC. Yes, but even though you have a right angle at angle B, which is coming from this triangle ABC, and even if you have a right angle coming from DEC, right, you need to have at least two angles in triangle ABC and two angles in triangle DEC for them to be similar, right? And it has to be the same corresponding angle. So it doesn't. So basically, my whole point for part D is even though you have a right angle on it on triangle ABC and a right angle on triangle DEC, it does not suffice for you to conclude that they're similar because you need to have two angles in a triangle for them to be similar because of the AA theorem, right? Angle, angle. So it's not just one angle. So yeah, this is correct. So okay, so this is sort of a pattern, this question, I would say. So here we have what are the next letters? We have BE, then you have GJ, then you have LO, and then you have QT. So I think it's easier for us to write down the pattern. Okay, so we have this pattern, right? And this is related to our alphabet. So we're going to have A, B, C, D, E, F, and then we have G, H, I. This is J, K, L, and this is M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Okay. Yeah, so some students, if you can figure out what the next pattern or next letters would look like mentally, right? Good for you. But for students who can't really see that, this is the way to go. So first, you have your alphabet, right, laid out and have your pattern with you, right? So observe. So if you have BE, right, first of all, you're starting at B. And actually, let's use a different color just so we know. Okay, so I'm gonna use green. Hopefully you guys can see that and distinguish that from the red. So if you have B over here, so if you count, yeah, if you count, so you have B. If you count five numbers, right, starting from B, so you have one, two, three, actually after B rather, because that's how this G is gonna work. So if you have 1, 2, 3, 4, and 5, right, you see that you land into G, right? And how do I know that? Well, if you continue on, you're going to see the pattern for L and for Q, right? So count again, 1, 2, 3, 4, 5. So now the next letter is L, right? So it's like the pattern is you're starting from B, you count 5, right, after B, and then you get G, right? And then after that, you count 1 to 5 again. After G, you get L, right? Count another 5, right? 1, 2, 3, 4, 5, you're going to get Q. So that's how you get the pattern for the first letter, right? So you count again, 1, 2, 3, 4, 5, you get V. So the next one is V. Now here's the question. How do you know what is the letter, right, after, like, let's say E? How do you know what's the next letter, why is it J, and why is it O, and why is it T, and what's the next letter over here. So all you have to do is, okay, so I'm going to have a box now. So this is E, and then you need to box J, right? And what was the next one? The next one is O. And then the next one is T, right? Okay, so I'm gonna use yellow just so you guys can follow. Okay, so in order to find the next letter after B, after G, and after L, and after Q, and potentially for this one, so if you count from B, right, it's the third one. It's the third letter, right? So if you have 1, 2, 3, it's the third one, right? After G, right, it's going to be the third letter after G. So 1, 2, 3. And then after L, it's the third letter. So it's 1, 2, and 3, right? Which is O. And then after Q, right? Because remember that's the initial letter, so you have Q. So you count 1, 2, 3, you're going to see that it's T, right? So you've probably guessed the pattern. So after V, right, you need to count 3 more. So 1, 2, and 3. That's why you know that this should be Y. So it's VY. So let's see what they said. So the letters B, E, G, J, L, O, Q, T form a sequence starting from the first letter of all the terms. G is the fifth letter from B, that's right. L is the fifth letter from G. Q is the fifth letter from L. So the first letter of the next term will be V. Okay, this is right. First paragraph is correct. Second, now for the last letter of each term, J is the fifth letter from E. O is the fifth letter from J, and T is the fifth letter from O. So the last letter of the next term would be Y. Okay, so they're using a different pattern here, which is, okay, for the last letter of each term, J is the fifth letter from E. Okay, so they're using E, right? And they're counting 5. So that's true as well, right? 1, 2, 3, 4, 5. And then they're saying if you start from J, right? 1, 2, 3, 4, 5. That's the fifth letter. Yeah, so this could be right as well. So yeah, there's a lot of ways to get to your final answer. So, and then the next one would be 1, 2. So after O, you count 5. 1, 2, 3, 4, 5. That's why you get T. And after T, you count 5 again, right? 1, 2, 3, 4, 5. That's why you know it's Y. So, um, yeah, so this is another way to look at it. Solution is correct. Okay, so yeah, for this question, we need to find which investment produces a $5 hourly profit for a candy shop earning a dollar profit per pound of candy. Okay, so we have 4 options. So what we're going to do first. Okay. By the way, anytime you're trying to solve for a question, right? I'm speaking for science, right? And math. And especially if it's like a huge chunk of paragraph, right? Try to write the numbers on your own. So like just the keyword. So let's say you have $5 hourly profit, right? So write that down. Or even underline, but because we don't have that option over here, so I'm just going to write this down. So this is the $5 hourly profit. And then the next one is earning a dollar profit per pound of candy. Okay, so for the first option, so we have A. So it says machine with $6 per hour operating costs, and this is basically producing 10 pounds. So LBS is pounds, right, of candy per hour. Okay, so as you can see, this is going to be a little bit of unit analysis, right? Because you wanted to identify your net profit. Basically, that's the question. So net profit is with your operating costs, right? This is $6 per hour. And then you have to produce 10 pounds of candy, or you are able to produce 10 pounds of candy per hour, right? So when you earn that profit for your 10 pounds of candy. So net profits is basically subtracting the amount that you're earning for this one and the amount for this, right? So when you subtract, that's your net profit. So that's what you're looking for the $5 hourly profit, right? So that's basically your net profit. So this number over here. So that's why you know that for this, right? Because it's per hour, that means you're actually earning $10, right? For 10 pounds of candy that you're producing, right? So when you take $6, right, you subtract that from 10, you get $4 per hour, right? So this is actually your net profit. So yeah, that's your net profit. So you need to remember that you're subtracting $10 from $6. Now moving on to part B, right? Because they're saying that you have $11 per hour. So the worker at $11 per hour producing 15 pounds of candy. So you have 15 pounds of candy per hour. Okay, so great. So you have 15 pounds. That means it's $15, right? And because how do I know that this is $15? Well, you just have to multiply this, right? To 1. So this is 15, right? So we take 15 minus 11, minus $11. So you should be getting $4 per hour as well. So that's your net profit. Okay, so apparently so far for A and B, we're just getting $4 per hour, right? So we haven't really arrived to $5. So we need to go on and look for that. So for part C, so machine with $8 per hour, operating costs producing 13 pounds of candy per hour. By the way, the pounds is of candy, so we can just say pounds, right, per hour. So as you can see, we can say that this is going to be $13, right? So 13 minus 8 is going to be $5, right? So this is $5 per hour, right? So this is your net profit. So we can actually arrive to this conclusion that it's going to be C, because your hourly profit for a candy shop is going to be 5, right? So this is taking into account the operating costs, right? And also the amount that you're earning for the candy. So that's why it's C. And then for part D, just so you're interested, why it's not D, right? If you have the worker at $13 per hour, and then you have producing 20 pounds of candy per hour, right? So we're going to say that this is $20, right? So 20, right, minus 13 is actually $17. So we have $20 minus $13, so we get $7 per hour. So yeah, this is your net profit, which doesn't really answer the question because they're asking you to look for $5 hourly profit. And also, just so you're wondering, because I think earlier I just said, okay, so this was 10 pound of candy and this is $10 because the question says you're earning $1 profit per pound of candy. That's why I know that this is $10 and this is 10 pounds, right? So for every pound, that means if you have 10 pounds, you need to multiply that to $1, right? Because it's a dollar profit per pound. That's why I know that I'm supposed to multiply this by 1. That's why I get $10 every time I'm producing 10 pounds of candy. Makes sense? And this is 15 because it's 15 times 1. And then for 13, that's 13 times 1. That's why it's $13. And for 20, that's why it's $20. Great. Okay, so this is what they showed us, which is pretty much the same. So for part A, they said it's $4 per hour, and that's what we got. For part B, it's also $4 per hour. That's the net profit. Part C, it's $5. That's true. And for part D, it's $7. That's why it's C. That is true. So perfect. Nothing to correct. Okay, I guess we can move on to the next question. Okay, so because this is an easy question, we still have 5 minutes left, so I'm going to go over this, right? So first of all, you have a parallelogram PQ, and this is SR, right? So what do we know about a parallelogram, right? So if you have a parallelogram like this, you can actually say that the opposite sides, respectively, you can say PQ and RS, they're going to be congruent, right? So they have the same, so their sides are equal, right? Opposite sides of a parallelogram, they're equal. So you can also say that PR is going to be equal to QS, right? But you can never say that PR is equal to PQ, okay? That's just a no-no. So because I said the opposite sides are equal, therefore the equations such as 3x plus 5 is equal to 6x plus 2, right? So you can say that because it's a parallelogram and they're equal sides. So you have 3x plus 5 and this is equal to 6x plus 2. And the whole point of this is to look for the length of PQ, right? So you have to solve for x first, and then you take your x, you substitute that into 3x plus 5, and that's your side or the measurement for PQ. So you have 6x here. If you try to move the 3x to the opposite side, you get 3x. And if you move the 2 to the opposite side, you get positive 3, right? Because it's 5 minus 2, which is equal to 3. Dividing both sides with 3, you get x is equal to 1. So as you can see, once you know that x is equal to 1, all you have to do in order to find side PQ, right, is just plug x is equal to 1, right? So 3 times 1 plus 5, so that's going to be 8, right? So this is 8 units. And because we don't really have any form of units, right? We don't know if this is centimeters, so we're just going to keep this as units because it's only the side. So it should be 8 units. Yeah, okay, this is right. Amazing. So perfect, solution, and answer. Solution is correct. Okay, great. Okay, so I think this is an easy question. Let's run through this. So how many quarts equals 8 cups? So 1 cup is actually a quarter for your quarts. So okay, if you have 1 cup, by the way, this is just the standard unit of measurement, right? So this is something that they should give you. I don't expect your teacher would actually ask you to memorize all of the conversion. They should give this to you. So if you have 1 cup, right, this is going to be 1/4, and this is quarts, right? So it's a quarter. So this is essentially 0.25, right? So if you have 8 cups, right, so all you have to do is just look at the ratio, right? If you have, actually, maybe we can set this up as a ratio. So if you have 8 cups, right, all you have to do, right, think about it, right? What is the factor that you multiply to 1 to get 8? It's simply going to be itself, right? It's just 8, right? So that's what you do. So because this is multiplied by a factor of 8, then all you have to do is you take 1/4 times 8, so that's going to be 2 quarts. Make sense? So that's why you know that for 8 cups, it's actually 2 quarts. Right there, boom. Okay, great. So, yeah, this is perfect, so. Okay, so for this, I'm going to wrap this class up. Yeah, so before anything else, I just wanted to say thank you so much, guys, for coming in, for just sitting there behind the screen and just solving math questions with me. I think it's just like the effort of just sitting there attending my classes. That's like a huge thumbs up for you, just because I know right now it's a very difficult time for everyone. But I think the most important thing right now for you to stay productive is to stay on top of your studies, because at the end of the day, we all hope that everything is going to resume back to normal, right? So if you're prepared to go back to school with I guess if you're ahead, right, and if you're on track, then you should be good, right? So thank you. More power to you, and yeah, stay safe and stay home. This is Janine the Tutor, and thank you so much for attending my class. I'll see you on the next one. Bye, guys.